Everyone, and a very good evening to everyone. And so today I'll be talking about reversing Android apps for fun. Well, hopefully it'll be fun, and the talk will be beginner friendly, but the so the talk will be beginner friendly, and then it's gonna be like really basic ways of reversing Android apps, and hopefully it'll help you in the future when you develop your own apps and or for your employers. So a bit about me: I'm a junior app dev, and I aspire to be a security consultant. I work with OP Security Solutions and my own company Ideas. I've been working in IT for 5 years. I've covered infra, app dev, and user support, DB admin. And then just for the sake of legitimacy, I have a handful of technical certs, so I'm legit. And so I've won like a few CTFs locally, and like a bragging rights kind of thing. I'm number one in Hack the Box. Hack the Box is a platform for people to try out like hacking servers and all that. But then I think I'm number one because I'm the only one active. Yeah, and I probably in 5 years I want to be a carpenter because IT is getting really fast and it's kind of hard to catch up. Anyway, so on this site I actually have an online challenge, and you can visit it at gdg-challenge.opsecurity.solutions. It's a bit of a reversing challenge. I think it should start now. Just to show you. Yeah, so you can visit the link. The challenge is really basic, and there's only one prize. It's a 3 months subscription to Pluralsight. Pluralsight is a site that I use a lot in the past, and it has a lot of content for a lot of technologies. You want to learn Docker, app dev, or security stuff. It's pretty good. I recommend it. So here's the site, just to preview it a bit. Anyway, so a bit of a disclaimer. All the techniques provided in this talk are actually, I mean, it's like any hacking. If you've seen any hacking tutorials and all that, it's just a disclaimer saying that whatever I teach here is for educational purposes only. And if you do this for illegal activities, I'm not responsible. Yeah. Anyway, so the agenda is basically this. I'll talk about what reverse engineering is, and then some Android dev basics, what's inside an APK, which is an Android application package, and then some reversing tools that you knew that I know that are basic tools for you to use, and then the decompilation process, some examples, and then OWASP mobile top 10. So OWASP mobile top 10 is like a standard for securing your mobile apps. And then I also cover the solutions for the challenge, and then finally we go to the Q&A. So yeah, moving on. Reverse engineering. I'm not sure if you guys are familiar with that, but so the basic of it is to logically find out. I mean, to find the logical business process behind something. I mean, that's how I see it. So this is off site. It's logical backward analysis of a finished product while not being aware of the technical details. So you don't really know what is actually going on. I mean, what is the source code? Or you don't really see the source code or anything like that. You don't really know like the spec sheet or what is the technical implementation is like. But then you try to, so when you try to reverse engineer it, you're actually trying to come up like how this happens. When you click this, why is it doing this, or something like that. And yeah, so there are two types of reverse engineering. Static analysis is reviewing the decompiled code, which is what we'll be covering today. Dynamic analysis is so you can you can actually run the application and also see what is the output behind like every clicks or every behavior and everything. And then also you can check. So in client server applications like Facebook application or Twitter and all that. So you can also do network analysis. So when you click on submit a tweet, what happens in the background? It's posting something. So yeah, those are the things that you can do with the network analysis. So a bit of Android app dev basics. This is what I know. It's not really like a full-blown basic 101, but I know that when you want to develop Android, an Android application, when you launch like Android Studio, the option is to either use Java or Kotlin. And I'm only familiar with Java, not really familiar with Kotlin. And then, so you can use Android Studio to develop native application on Flutter. And so Flutter is a cross-platform option. And in cross-platform options, there's quite a few. So with Flutter, you develop the application in Dart, with PhoneGap in HTML, CSS, and all that. And Xamarin is in C#, and Ionic, I think the rest of it is in JavaScript. It's like a JavaScript framework. So what happens in cross-platform, in all these cross-platform options is you develop once and then you can deploy to Android or iOS, or like for the case of Flutter, you can also develop, you can also deploy to desktop application and all that, yeah. So, yeah. What's an APK? So an APK is basically, the name is Android Application Package. It's essentially a zip file. So if you actually change the extension to .zip, you can unzip it, and then you can see what you can extract out of it. So this is an example of what you can extract, and what is inside is actually the application resources, the assets. So if there's any images, you can see you can see them in the assets, and if there are any native libraries like maybe something to scan QR code or and all that, it's going to be in the libs. And then classes.dex is basically so all those Java files that you create in Android Studio, it will actually be compiled into classes.dex. And I'll explain further what that is. And then you can also see the signature, the manifest. And then the manifest is a list of what activities are in there. What pages are in there, and then what permissions you can use to what the application can use. What permissions the application needs to run the application in your phone. So that's what's inside a manifest. So continuation of that, classes.dex is actually so again, like I mentioned earlier, it's all the Java classes that is used to run the application, but it's in DEX format, which is the Dalvik executable. So Dalvik executable, what Dalvik is so I'm not sure if you guys are familiar with Java. When you develop in Java, there's a thing called JVM, which is a Java virtual machine. So what happens is Java will actually, what you write in Java will actually be processed by JVM. And once it's processed by JVM, it will be translated into whatever your machine is running on. Like if it's Windows desktop application. So in Java, you say click button, something like that, and then it translates into whatever Windows understands. It's something like that. And the binary Android manifest, as I mentioned, is the Android manifest file. It contains the permissions, the activities inside, and And then there's a compiled resources, resources.arsc, and then so that is actually I'll show a bit of this later. What's inside resources basically is the the UI markup. So the page markup. So it's the design of the application, the content. It's basically the design of the application. The pages that is used for the application is inside the resources, and there's also uncompiled resources as well. So that's also the same. So for decompiling applications, one of the go-to tools is actually apktool. What apktool is it's based off these two technologies called Smali and Boxmali, and what they are is actually they're an assembler and disassembler for the DEX format. So the DEX format that I mentioned just now, the classes.dex. So what Smali or Boxmali does is it decompiles that into like a machine language kind of thing. or assembly language. And then this assembly language is the one that is understood by Android. So in my previous example, I mentioned Java VM. So in that's for like your desktop applications or like your servers and all that. But in Android, it uses the Dalvik VM. It's about the same thing. It's just interpreting wherever the code is into something that Android understands. And Boxmali is the one that disassembles the classes.dex into Smali files. And the Smali syntax is kind of like assembly language. And then the Smali files are, so that is what is actually readable. It's actually a readable form of the Android bytecode. And what bytecode is, it's a program code that has been compiled from source code into low-level code designed for some software interpreters. So basically, again, like I mentioned, it's just it's the language that Android understands. And also these Smali files are technically a readable form. And Smali also, apktool also decompiles the resources in the APK. And these are the example of running apktool. So apkd is for decompiling, and apkb is for recompiling back. I'll have an example later. And the other one is jadx-gui. So jadx-gui, if you look that up, you can decompile this code, the APK, into Java classes. So this is more readable. This is more like what you see in the Android Studio or whatever your preferred IDE is. And when you're reverse engineering, when you're trying to find out like what is the encryption like, what is the like when you click this, what actually happens in the background when it tries to validate the process or anything like that. This is where you can see it in a better way, rather than the apktool. I'll show a bit of it later. So it does this by converting the DEX file to a jar file, and that jar file it's converted into it's decompiled into separated Java classes. So decompile. So okay, I think I messed up the sequence for this. It's supposed to be this first. Anyway, so decompile. There are no tools that it can reliably decompile applications or to like 100% source code but then what we need when we want to reverse engineer an application is we just need to understand the application. So any human readable code is good enough. And again, like I mentioned previously, the two methods are apktool and jadx-gui. So reversing tools, as mentioned before, apktool, jadx-gui, and then Visual Studio Code That's what I use for reviewing the code. And actually, you don't really have to install all these tools. You can actually just, so if you want to decompile quickly, like if you want to do it from your phone, there's an application thing. It's called Show Java. Show Java can actually decompile APKs in your phone. And then another way is if you can extract the APK from the phone, and then you can upload it to javadecompilers.com/apk. This will actually show the Java source code. And yeah, an example of like a really simple example of Hello World app. And you can see here, this is the main activity. And then, this is just a simple Android Java Android application, and it only outputs a Hello World. This is the Java class, and then this is the basically the UI markup of the application. So the one that I mentioned earlier on, Smiley, this is how it looks like. I don't really understand it, 100%, but I do understand that that there are some places, so if you can see here, constant string v0. So all this is, if you want to understand further on this, you can actually look up a bit on assembly language. So if you learn about like registers and all that, there's a bit of similarity here, and so this is the same as this class just now. So what happens here is on create, you can see as on create as well. And then, but this is actually a different file. I actually modified this. Instead of having hello world inside the markup, I actually put it inside the code. So you can see hello world here, and then this will actually set the text, this text view to the hello world string. So yeah, this is Smiley. And then in jadx-gui, you can actually see a better view of the code. So this is the compiled code, and you can see the differences a lot. Like how do you? This is just a simple example. If it's a really complex application, it'll be like a long list of functions, and processes and declaration of strings and all that. But with this, you can actually see a better view of the application now. And you can, but then the gripe behind this is you can't really, if you want to recompile this, you have to recreate the project and like recreate, grab the Java class and then recreate the whole thing lah. You can just as easily as run apk jadx-gui and then ask it. You change something and then ask it to recompile. It doesn't work that way. But then in apktool, you can actually do that. So a bit of a demo. This is using apktool. Let me just open this. Hopefully you can see the screen on the. Can you see the screen on? Yeah. So for the hello world just now, this is the decompiled code in Smiley. So we see the main activity, and you can see the hello world here. And you can actually decompile this. So this is decompiled already. I ran the one that I showed just now, and then hello world. Hello world.apk. So this is what I did. And then it decompiles to this. And yeah, as you can see here, when you decompile using apktool, you can see the source code of, the Java code is decompiled into Smiley. And yeah, this is the Smiley code. And then you can see the resource file. And if you're familiar with Android, the page that the main activity page is in resources, activity main. Wait, so this is the binary format. And then, sorry. I think it's here. Yeah, activity main. Never mind. I think it doesn't really. Oh yeah. So what I did here was I decompiled the application, but then I ran with -r, which is to not decode the resources, because somehow in my machine, if I try to decode the resources, I face an issue where I cannot decompile because I'm missing some dependencies or something. But yeah, so now if I try to recompile this with hello GDG, okay, no, whoa. Let's just do this. Whoa. Take it to be hello. So apktool will actually rebuild the application with the changes that I made. So this is a really simple example, but imagine you have an application that that actually detects you're running in root mode or something like that, or it detects that you're not supposed to be the user. It probably detects it by like email number or something. So with this, we're decompiling it and then modifying it. You can actually change the logic behind the application and then recompile it, and then you can run it. So I think it's going to take a while. Let's see. Yeah, I'm actually trying to navigate in the application. So this is a problem. This is the problem if you don't have a strong, a powerful enough computer. Everything lags. Let me just check here. Yeah, it's taking a while. Okay, so it should be building it now. Do this. Okay, so the APK is compiled, and the new APK is inside here, inside here, and I think I can do an install. Sorry. ADB devices. ADB connect. Hello. ADB connect. Personal. Yes. Hello world. Hello. So I'm gonna try to install the application through ADB. ADB is a Android debugging bridge. You don't really need it. All right. So what happens is this. So when you actually decompile the application and then recompile it, you also need to make sure that the application is signed properly. Yeah. So to sign it, you run this. It's a really long. Hope I got it right. Okay. So I'm not sure what's going on, but it is. So I think I'll just continue on. What happens is just it's gonna change the hello world to hello GDG. Yeah, and then yeah, with that is the demo lah. Okay, moving on. So the next bit is a bit on mobile security. So we touched on reversing just now, and with mobile security, there's actually a lot more that you need to cover. It's not just trying to circumvent people's reversing your applications, but also you need to know like a list of checklists that you need to ensure that it's secure. And okay, so OWASP Mobile Top 10 is a project by the Open Web Application Security Project. They have this top 10 issues. Like it's a list of top 10 problems for different platforms. There's web, there's mobile, there's I think that there's a few other top 10s as well. And for mobile, these are the lists that they've given. And just a bit of each one. Improper platform usage is, I think one of the example is like, Apple Touch ID or the Face ID. Some applications, they try to what do you call it? Trick users by using Touch ID. They say it's actually to grab like health benefits. I think it's in one of the applications. It was like some fitness tracker or something like that. And what happens is Touch ID is in Android and in iOS is actually for purchasing as well again. And yeah, so they trick the users into thinking that they're using Touch ID to grab data of like the health data, like through the fingerprint, but actually it's in the background, it's doing purchases on your behalf. So which is a bad thing. And yeah, because with Touch ID, you can actually access Apple Pay and then authorize the request to pay again. So that's one of the issues with one of the that's under improper platform usage. Basically, improperly using the mobile APIs to trick users lah. And insecure data storages. So in each application, I mean, for each application, sometimes you actually store sensitive data inside the phone, inside like a local database inside the phone. And you may think that no one's going to access it, but people can actually reverse engineer and then grab the data, or maybe like they create a new application that accesses your mobile's application, mobile's API or functions, and then grab the data through there. So what you need to do is actually to properly secure that, protect it, like encrypting the data and all that. Insecure communication, in hindsight, I mean, the basic of it is ensure that you use proper encryption for your communication. So if you have a client server application, make sure that you use SSL or TLS. And insecure authentication is just a bypass. I'll show a bit of this later, some examples. And then insufficient cryptography, basically, it's the same thing as the authentication or authorization, whereby you use weak encryption methods or encryption, like you use MD5 for your application, which is now technically it's so weak that it's so easy to reverse to decrypt whatever that you use, whatever that you try to hide using MD5. Client code quality is more on like bad server-side coding. So in some example, I think like some sites, they have coupon codes. So with coupon codes, by right, you can only use it once. So, but in this implementation, you probably put some validation in the application that you cannot reapply, or you cannot apply multiple coupon codes. But then on the server side, it's just like sending a request once. I mean, it's just sending the request, and then it doesn't really validate whether that coupon code has been used. So you can just resend that same request multiple times, and then you can get 100% discount, or even like a negative outstanding, something like that. And so risk of code tampering is more on, I mean, code tampering is just, again, what we did. It's a bit similar to reverse engineering. So reverse engineering is just reading the code. Code tampering is you can do what I did, modifying the application. So with code tampering, a way to actually circumvent that is to make sure that you have checks in your application that ensures the integrity of the application, that it's not tampered, it's not changed or anything. But again, all those circumvention will only like prolong the analysis, the reverse engineering effort. It won't really like stop people from hacking your application, but with all those in place, you can at least build a fence around your application. And then extraneous functionality is so in some applications they deploy the code like a code for beta users, and actually that code is only if like you're a beta user can see the new page. But the thing is, you deploy that to the client, to the application again. So when people reverse engineer that, they will actually see the new functionality or the new page or whatever like that you push. So make sure that you don't actually deploy beta or like extra functions that you don't need in your deployment, in your release for the public. So yeah, these are some of a statistic of the violation rates. I think this was taken a few years back. Yeah, reverse engineering is still at the top, and actually by that I would say insecure authorization or authentication does happen a lot more recently as well. And yeah, extraneous functionality. So when you see like some people, like for the case of Instagram, I think when they were releasing stories, some people got it, some people don't. But actually, probably if you decompile the code, you can actually already see the code is there. It's just that it's not activated for your account. So say you have something like that, but then you don't really secure it, then people can use like stories. I think in the earlier versions, some people can view even private stories or even modify stories. Yeah, so those kind of thing happens. Yeah. So yeah, at the end of the day, when you want to include like all this beta or extra features, make sure that you also secure it on the backend as well. So a bit of a demo for the OWASP mobile top 10. So the demo for this is just like I'll just be covering on the API side. Tools, actually, you don't really need all these tools, but I use Burp Suite. It's just to intercept the APIs, the API calls from the application, the decompilers to view the source code. ADB is just to push push the application into the mobile and everything. This is my example. It's actually like a chair app, but I couldn't finish it. I thought because I submitted this talk like a week ago, and then I was trying out like different stacks. I don't know. I think I overestimated my my capability. So what happens now is there's no UI. It's just I finished the APIs, but there's no UI to it. So in hindsight, it's just this list of functions. Users can log in, can view their own profile, they can update like payment information, which is sensitive, supposedly. Even profiles are actually sensitive only to you in the case of this application. And then they can see a list of shares or book shares and see the list of book shares. So since I couldn't make the UI, I just created like a mock-up of the UIs, just for you guys to imagine how it looks like. So yeah, login will look like this, and then the profile will look like this, and then booking chair. The payment info, you can see card numbers, expiry, CVV, and then this is how it looks like for the like the list of chairs, and then you can choose the size, and then this is like your list of book chairs. Yeah, so for the case of insecure communication, I'll show how people can actually intercept the what do you call it? The communication between your application and from your mobile phone. So let me just see if I can. I probably don't have like a good example, but then so with Burp Suite, what happens here is that I installed like my own SSL as a. So I'm not sure if you guys understand how SSL works. It's basically like signing so it's just wrapping the content of a packet or a request inside like a lockbox, something like that. And that lockbox can only be opened by a specific key. Yeah. So what happens here is that I installed like my own key inside the Android, and then moving forward, any application that uses HTTPS, I can unlock with my key. So I can see any applications requests. So for the case of this, mobile phone, I just installed this application that we use. It's called underarmour mapmyrun. And then in underarmour mapmyrun, if you can see here, there might be some sensitive info, but I'll just change my password later. Let's see. So where is it? Entity. I think I need to try WA scope. Then tools. Oh, no. Let me just check. Oh, shoot. This open. I'm not sure why it's quite slow. Yeah, it's fine. Okay, let me just go back to this. So yeah, for the case of APIs, let's just imagine this is the API. I mean, this is the API, but then yeah, it's running locally at the moment. But what happens is if I run like a request here, and then I can see the request being intercepted. And yeah, for the case of this, yeah, let's just okay. Yeah, so change this. She have the API in published in GDG-API.security solutions. Yeah, so okay. For this case, I can't really show how the interception works, but what happens is I can see all the request that's being made by an application, and then I can modify it or repeat the request or change, yeah, and all that. But so for the case of insecure authentication, in some implementation, you have guessable auth tokens or like weak auth tokens, and with that you can actually cause like account takeovers. Account takeovers is yeah, someone just using your account now. So for the case of this one, my implementation of this is like it's really insecure lah, because so what happens here is, and if you guys are familiar with Node.js, so this is for APIs, you use JSON web tokens because APIs are stateless. They don't really use cookies, right? So that's why in this implementation, I written a JSON web token once a person is logged in. But then the issue here is my token secret. So token secret is in JOT implementation. What happens is you can have a message that you want, and then you sign it or you encrypt it with a token. And if you have a weak token, what happens here is someone can just modify that token and then reuse it. So for the case of this, since I have a weak token, I can just take this and put it here, and then I can see, okay, suppose the ID is 5, but since I know the secret, I can just change it maybe to 1, and then use this. The releases here lah, in the get profiles, and with this I got I can actually view someone with profile. Someone with user ID 1. So the issue in this case is actually implementation of your JOT, basically. I mean, you have a secret key, but then it's a weak secret key. And in some cases, also, some people actually don't use like a proper way to verify the signature. Yeah. So again, you may think that, yeah, I'm not going to do this, but I've seen this in the wild now. And in some cases, you can actually see IC numbers, you can see addresses, emails. So if like an attacker has all this information, what they can do is spearfish you or go to the bank and tell them that they know all this information, like your date of birth, your mother's maiden name, or whatever that is inside the application again, and could even be your card number. So that's why it's really important to have like a good implementation of all these things. Yeah. And insecure authorization is is basically you have an endpoint that looks like this: payment info / user ID. And what happens here is you can use anyone's ID, even though you're actually logged in as someone else, but you can see like other people's ID. So for the case of this, it's this one. This one. So I'm actually user ID 1, and I got an error. Yeah, sorry. I think there's a wrong implementation here. I think for this example, I actually put it here. Chairs, book chairs. So actually, I'm user ID 1, but I mean in the code, it actually checks the user ID, the book chairs user ID, and then because the user ID is actually inside the parameter, instead of like checking it from the token or cookie, what happens is I can just change this, then I get for user ID 5. Sorry, 2 now. Yes, 5 doesn't have any. So I mean, this is just for chairs. But then what about like say you have a e-commerce site, and then you can see someone else's transactions, and you can from there, if you do like data analytics, you grab everyone's transactions, and then you can gauge who is the richest in this platform and who spends the most. And if you want to do like a crazy spear phishing campaign, or you want to target the person, you can easily like send them like a promotional email, and then when they click on the email, it actually directs to something else, and you can get inside their PC and then install malware and stuff like that. So that's how it can actually impact a person from an attacker's point of view. So that's why you don't really, I mean, as devs, you don't just create applications, but you have to make sure that you secure them properly. And in some cases, you can also see admin and like admin only stuff, or like the admin panel. So yeah, those are really you have to make sure that you secure them properly. So from reversing, I actually have a few personal projects. It's I know, some are kind of finished. I mean, some are just on the side that I wanted to check out lah. So one of the things is the underarmour thing. So I checked out the APIs and then created a script that can show this lah. Because in the initial page, it doesn't really. I mean, in the application itself, it shows like ranking and all that. But then with this, I can actually show this like in a TV or a dashboard or something like that. Because for the underarmour mapmyrun, I actually use this for at my work. We actually use this for a challenge, for a running challenge. Yeah, so I can like recreate the UI basically. And another one is bibd. So for the case of bibd, I think yeah. So I've probably, I mean, permission wise, they don't really have any clause on reverse engineering, so that's why I did it. But then one of the things that I wanted to do was I knew that they have that quick pay thing, and then I wanted to create like my own quick pay thing. So I can generate. It's kind of like WeChat or Alipay. So you can generate your own QR code with the amount that you want, and then with the same platform, you can scan it, and then it will actually parse the data inside that QR code, and like you can have the amount and everything now. But yeah, for the case of bibd, I actually found the list of APIs and then tried to work out like which one does what, which one is for like getting the value in my bank, and this is not the real value, of course. And then I can also I found out like a way to get PIN, because I use the cardless withdrawal a lot. So instead of going on the application, clicking multiple stuff, I just go to this. So this is a web-based application. I just go to my web-based application, click on PIN, and it gives me the PIN. And then yeah, and a bunch of other things as well. Like I don't really have to go on my phone. I can just do it from my laptop lah. But it's a bit risky. It's a risk that that I've accepted lah. Yeah, so I'm not sure if you guys did the challenge, but I think it should be ending now. If no one did, then it's fine. But I'll just show like the solutions for the challenge. So the challenge is actually it's an application. Sorry. Yeah, so it's actually this application. I'm not sure if you guys have played CTFs before. Yeah, so in this CTF, there's a few questions, and one of the things that I mean, so okay, so for this application, I'll just show you like how I would do it lah. And okay, so it starts with the easy, and then we go to medium to hard. And in the easy one, it says that what is the name of the first function in the main activity. So if you use Java decompiler, the website, and when you decompile it, you can actually see the source code lah. So for the first question, it says that find the name of the find the name of the first function. So this is decompiled in maybe. So this is decompiled in apktool, and I think in here as well you can actually see the name of the first function. It is which one is it? Let me just open that one. No. Sorry. Yeah. Yeah. So you can use that, or you can also use the jadx-gui. So with jadx-gui, I think it's easier for me. So it's actually just two files, and the first one is so you can see the first function is this one. This function is a flag. So yeah, you can just submit this, and you get the correct answer. Yeah, and then the second one is what is the value of the secret key in the main activity. It's just this one, this long secret key. And if you submit this, should get correct as well. What is the value of the other secret key? So like I said previously, you can actually find like different areas for storing like text-based like resources. So you can actually find that one in resources. You should be values, and then strings. This is like a common place people use to store their keys as well. And you can see it's the other secret key, and yeah, submit that, should get it. And then find the name of the company that created the application. For that, you can actually see that here in the signature, it's click company. And then for the hard one, it says that using the I think it's the first one, using the encryption algorithm and secret key in the secrets found in the previous question, decode the string. So this for this one, what you do is you go here. Okay. So in the crypto utility, you can see what it uses for the encryption, and you can actually just Google this, like copy this and then Google it, and you find out that it's using this thing called this one called Vigenère, I think Vigenère decoding. So you can use that. But then the first one is a base 64, because if you read the code here, it says it encodes it in base 64. So do this. And then for the key, you use the initial key. So there's two keys, so you can just try out either one, and which one gives you the yeah. And then here and then it says Mr. Brun that GDG is fun. You submit that, it's correct. And then find the hidden API. For that, if you read in the main activity, you can see there's a secret API. And then what you do is you can load up like in Postman or in other applications. But for the case of this one, just put it here in the VS Code REST client, and then wait, let's do another thing. Compose. Yeah. Then yeah, you can get the answer, and then you can submit it. Yeah. So all these techniques, it's basically what I use to find out like what's inside an application, and yeah, for maybe like these are really basic techniques lah. But what you can do with it is like as a conclusion now, as devs, yeah, security is not really security. If you think that you can hide your stuff in the application without like encrypting or proper protection or proper like proper checkings of your APIs, that's gonna be really bad. And yeah, if you wanna like do more obfuscation, do enable Progat if you use Android. Progat is a way to obfuscate your application code. So when it's decompiled, it's going to be really messy. It's going to be like there's a lot more extra stuff, and it's a lot harder to reverse. And just because it's tedious to reverse engineer doesn't mean no one will try it. Yeah, I've tried it, and I know that there are other like really crazy reverse engineers that will try it. And you can check out this list. And for aspiring security persons, why you want to do this? Overseas there's bug bounty programs. So if you're like looking for extra cash, this is an area that you can look into. These are the sites that you have for bug bounty programs. So in bug bounty programs, basically they just like there's companies like Yahoo, Facebook, Twitter, Google. So all those companies, they have a place to report lah. Yeah. So all these places like Razer, kan, you can see that broken access control allowing other users' bank account to be deleted. You can see that. I mean, that company is Razer also, but devs always make the same mistakes. And then, yeah, can see this is the reward for that 1,000, and then there's reward 6,500, and then for Grab, Android, and secured link, there's another way lah in mobile applications. Yeah, there's a few lah. I mean, there's this kid from Uruguay. Yeah. I mean, for him, I think he found like a bug in Google Cloud Engine or something like that, and then he got rewarded like 30K for just trying to find out other people's flaws, But then it may cost that much to reward the security researcher, but it is actually cheap to the companies, because imagine companies like Google, and the issue that was found is they can hack into Google, they can grab anything like in Google's infrastructure. If not, I mean, if like a bad attacker got into that, they won't report it. They will actually like grab everything, and then it creates more losses to Google. That's why they have like this huge bounty rewards. And then there's a few people that's gotten like $1 million out of bounty programs. Yeah, so that's actually like a side thing that if you guys want to look into, it's an avenue to it's like freelancing but in security lah. Yeah, and yeah, I guess that's about it lah.